Okay, I was just looking at a video about patterns, which is going to lead to a more formal approach to how we solve problems with patterns. But so in the unit, we've got to talk about there are different patterns in mathematics. You see patterns in nature. I think this is a conch shell or something like that. But once we know what patterns are, where we can identify patterns, then we can actually use that to predict. So recognizing number patterns is an important problem-solving skill. If you can see a pattern when you look systematically at evidence, examples, you can use that pattern to generalize what you see. Okay, so this is just an introduction to patterns. Okay, so there's different sort of patterns. The first one is called an arithmetic sequence, and we're going to do a big lot of maths on the arithmetic sequence. And that's just a group of numbers that follow a pattern based on adding or subtracting, and this is called the common difference. Okay, oh, sorry. So this is the common difference. Like in this pattern here, we're just going up by threes. Okay, we're just going up by threes. So whenever you have a pattern that goes up or down by the same number, the exact same number, we call this an arithmetic sequence. Okay, and this one, the common difference is 3, and that comes up later on. So again, we're just looking at identifying types of patterns. So yeah, take some notes if you need to, but we're going to do a big topic on this anyway. Okay, come across when you're ready. Okay, the next sort of pattern is called geometric sequences, and instead of adding, it's a multiply or divide. So in this pattern here, we'll be going from 1 to 3 to 9 to 27. We're multiplying by 3. So whenever you have a factor, which can be a whole number or a fraction, multiplying by a third, multiplying by half. So this is a multiply or divide pattern spotting. Okay, and then it's called a geometric sequence. And again, we do a big lot of mathematics on that sort of stuff. So take some notes if you need to, but come across when you're ready. Okay, these other types of patterns, you just sort of see. You don't necessarily see them always in nature, but there are patterns. So the first one's called triangular numbers, and they form triangles. And sometimes you can see, like this is going up by 2, then it's going up by 3, then it's going up by 4. So it looks like there is a pattern there, and obviously there is, but it's not the same number, so it's not the same difference. Difference is increasing, so it's not an arithmetic sequence, which is what you did on the previous page. But all these ones can be formed into dots that make a triangle. Okay, and these are the examples just there. Okay, so copy that and come across when you're ready. Okay, the next one we're looking at is square numbers. Okay, and square numbers is just 1 squared, 2 squared, 3 squared, 4 squared, 5 squared. Again, you sort of recognize those anyway. But sometimes patterns there might be a pattern like n squared minus 1. So again, necessarily don't have to study them, they don't come in nature, but patterns might have something to do with squares, but they'll not be exactly the squares. And the reason they're called squares is because when you draw them, they make a square. Okay. Next sort of pattern is called cubic numbers, and this is 1 cubed, 2 cubed, 3 cubed, 4 cubed. And obviously, if you draw a cube, if you drew a cube, there would be like 2 cubed has 8 vertices. Okay, so again, this has a diagrammatic representation, and so does cubic numbers as well. And again, you recognize them sometimes quickly, and sometimes you might see them a bit later on. Okay, so copy that and come across. And the last type of pattern numbers we're looking at is this sequence, which is interesting. It comes in nature, and you could do a whole assignment on Fibonacci about where it came from. You know, obviously he's named after this mathematician who was born in Italy, and Fibonacci introduced Hindu-Arabic numbers into Europe. Okay, but with this sort of pattern here, in a Fibonacci sequence, it starts with 0, then 1, and then 0 plus 1 is 1. 1 plus 1 is 2, 1 plus 2 is 3. So to get the numbers, you add the previous terms. So it's down here. So the Fibonacci is found by adding the 2 numbers that come before it. And you can get Fibonacci type sequences that aren't a Fibonacci sequence. So for instance, if I start with 3 and 4, a Fibonacci type sequence could be 7, 11, 18, 29, but this isn't a Fibonacci number series, it's a Fibonacci sort of style, but it's not actually a Fibonacci sequence because it doesn't start with 0 and 1. Okay, so basically I was just introducing you to patterns. I'm not sure that there'll be any exercises to do, but just that you recognize there are patterns that come in nature. Okay, bye.